Okay. So far we have done a feature engineering and like data analysis part we have done. Now we are trying to do a feature selection, means which are the columns are important to predict the sales price. That one we can do by using a correlation. Okay, how to find the correlation for any given data? We just have to say data you call, which data you have saved in a HP data. I just say correlation. Okay, CORR. It will give the all the correlation matrix it will be given. Okay, in case I would like to save this particular file, then this particular output in some variable, I just say COR underscore data. Okay, correlation data. I just said correlation data. But when we take that correlation data in a table format, we may not be able to interpret very well. So what we will do, we will take one graph like visualization, that is nothing but SNS dot. We use a heat map to visualize this correlation data. Okay, I will try to visualize that correlation data. But this visualization is very messy. In case I just want those correlation values also, so I say annotate is equal to true. Then it look very messy when we do that one, right? So we are not able to see anything. That's the reason what I will do. I will say plot dot, okay, figure. I will increase the figure size. I say 20 comma 15. Okay, much more bigger figure size I will take, so that it may look bit better. Okay, it look bit better now. Okay, and in case you would like to take something like color, you would like to change the color, like we can say see color map. Okay, color map, I can take it in a blue. Okay, we can take a blue, or blue is not available, I think some of the color here it is given. I just take red, yellow, green. Lowest will be in a red, yellow will be in a center. Then if you do this mistake, you will get those values. Okay, we can see how it will look. If I give the plot dot show, it will be better, like plot dot show. Okay, so we got this correlation matrix now. Okay, here wherever you have red color, that means low correlation it has. Wherever we have a green color, that has a high correlation with the sales price. I just want to more check that how they are correlated all other variables with the sales price. Okay, wherever we have a green color, that is better. Okay, zero point 0.5 and above. Below zero point 0.5, wherever we have, it will be in a red color, and yellow color is a moderate correlation value varies from the 0 to um, how much we say -1 to 1. Negative values means low correlation, means negative correlation. If that increases, this decreases, like that. And positive correlation means we will be having a if sales price also increases, if that variable also increases. Then zero correlation means there is no relation between them. But we need to have a high correlation value. So I don't want this particular chart. I just want to select the feature which has a at least correlation more than zero point 0.5. Right? How can we get that one? By using this correlation data we have. So what I will do, I say I just want to get correlation data for sale price, because that is the output variable. Okay, all the correlation with the sales price we have been got, all other variable with the sale price. Okay, but I need this one when there is a value is more than 0.5. Okay, the value which are more than zero point 0.5, I just want to say selected equal to, right, selected equal to, if correlation value of the sale price is more than zero point 0.5. If I check selected, okay, is not true or false, right? So selected, what I will do, I just take a sale price in that. Okay, that will be a single array. Okay, in that array I just say selected data is equal to, or that is nothing but within this selected. Okay, selected, I say uh, sale price. Okay, or selected, how can we say, okay, selected, selected greater than 0.5. If I do that, now we can check selected data. Okay, only above zero point 0.5 we have been taken, means within that selected array we just selected more than zero point 0.5, we have been in that array which is more than zero point 0.5, we will be filtering. Okay, then we filtered, we got to know that there is a overall quality is influence on a sales price, and much influence is by the area. Okay, the live area, living area will be influencing more comparatively other parameters. They are year built also has an influence, modification year also, but not that great one. Okay, I just want to know the columns, which are the columns, selected columns. I just want to say selected feature, selected underscore columns is equal to, I just say selected data dot index. Okay, index of that means the name of that I just want to take. So now I say selected columns, I can check, these are the selected columns we have. Okay, these are the selected columns we have, mean these are the columns out of 81 columns. If I check length of selected columns, 11 column we have been selected for the analysis, not all the columns, right? Only 11 columns, like out of 81, another 70 columns, they are not finding that much importance in terms of analyzing, means they are not having that much importance in terms of the sales price prediction. Out of that 11 column, one is the sales price itself, so 10 input column we have. Okay, only 10 input column we have for the selection. That is the final conclusion I can do. I can say that 10 important inputs drive sale price of the house, right? What are those columns, what are those value variables, we have to say this one. Okay, these are the variables which drive. Okay, this is a how future selection will be taken place in a pandas by using this Python. Okay, this is the overall, this entire process so far, whatever you have been learned from the EDA, like from connecting a data, okay, from the CSV file till this selecting 11 columns, whatever you have done, huh, that is nothing but a exploratory data analysis. All three steps together, like data analysis, then future selection, future engineering, all three together we say exploratory data analysis. Now I can check that, I can say that housing price with that selected columns. Okay, these are the columns we have. Okay, 11 columns we had. Okay, these are the columns will be used for the final analysis. Like I say, final data is equal to this one. Okay, this is the data I will use it for the further model building and all. Okay, if you are building any machine learning or deep learning model, then we use this particular data, like which we selected. Like I say, final data dot head. Okay, we can check these are the data, or I can say final data dot info. You can check that is there any other um, like missing values are not there, all are clean. Okay, all are in integer, all are in perfect format, everything. Okay, just you would like to take this, export this data, like further you would like to connect it somewhere in a machine learning later course. Then what we have to do, we have to say that final data dot to csv. I just want to convert to csv. If you like to excel dot excel, you to excel you can do to csv. I say data underscore model, like model data, I say dot csv. Okay, csv. Just if I execute this code to csv, you will be getting that in your here in your folder where you were working now. There, see data dot csv has been done. You can download that, like you can check the data which you have been connected, right? If I say model dot csv, like this. Okay, this clean model, clean data you have been generated by using a python. Okay, by using a python with the exploratory data analysis. This entire process is called as a exploratory data analysis. Okay, we will summarize what are the things we have learned so far and what else you will learn in a coming sessions also in a next video.